Hello everyone, welcome to our channel. Let's learn together. In this video, I'll be talking about the standard forms of Laplace transforms. Okay. I hope you remember the definition of the Laplace transform I have explained in the previous video. Please do check that video. Okay, first, let me quickly write the formula of the Laplace transform, which you have to remember. Okay, that is 0 to infinity e power minus st f of t dt, which is equals to f of s, right? Okay, so before going into the standard forms, I just want to give you a small, I wanted to explain you something. Integral uv formula, right? uv dx. So what is the integral uv formula? U into integral v dx minus integral of differentiation of the first term, that is u, into integral v dx into dx. So instead of remembering this, I just want to tell you a small trick. For example, take x into sin x dx. Okay, x into sin x dx. This is in the form of u v dx, right? So instead of applying this formula, if you want, you can apply, but I just wanted to tell you one small trick. So for first step, what you have to do is select the terms whose differentiation steps becomes constant easily. So here these are the two terms, right? X and sin x are two terms. So what you have to do, select the term whose differentiation steps becomes constant easily as the term 1. So x becomes easily the constant, right? So select this as the term 1 and sin x as the term 2. So that is the first step. What is this next step? Step 2 is first term into integral of second term. And third step is write alternate signs. Fourth step is again derivate updated value. Okay, derivate updated value of first term and integrate second term. Okay, so these steps are just the alternative of this formula. Okay, just in a simple way. Okay, first we have to identify first and second term. Second step is first term into integration of second term. First term is x and into integration of second term is integral of sin x is minus cos x, right? Now what is the third step? Write alternative signs. Now you have here it's plus, right? Now you have to write minus. Fourth step is again derivate the updated value of first term. Again you have to derivate the updated value of first term. So first term is x and the updated value of first term is here, that is x. So derivation of x is 1 and integrate the second term. With second term, updated value of second term. Second term is sin x and updated value of second term is minus cos x. So integral of minus cos x is minus sin x. So this is simple, right? Instead of remembering this whole thing, so minus x cos x plus sin x. Okay, so just a simple thing. If you want, you can follow this formula or you can follow this thing. Okay, now let's start with the standard forms of Laplace transform. Let me erase. Okay, what is the first standard form? So the first standard form is if f of t equals to 1, what will the Laplace transform of f of t, which is Laplace transform of 1 is equal to how much? So we know the formula, right? Which is Laplace transform of f of t, which is equals to Laplace transform of 1 equals to integral 0 to infinity e power minus st into f of t. F of t value is 1 into dt. So integral 0 to infinity e power minus st dt. So what is the formula? This is in the form of integral e power ax dx, right? So what is the formula? Integral e power ax dx, which is equals to integral e power ax by a. Do you remember this formula, right? So e power, what you will get? E power minus st divided by minus s into, you have to apply the limits, right? 0 to infinity. So what you'll get? Take this s outside. You just have to, these limits are for t, right? dt means, so these limits are for t. So minus 1 by s into e power minus st 0 to infinity, that is minus 1 by s into, just substitute 0 to infinity in place of t, which is nothing but e power minus s into, so upper limit minus lower limit, upper limit is infinity, that is e power minus infinity minus e power 0, right? Which is equals to minus 1 by s. E power minus infinity is 0 and e power infinity is infinity. Please remember this, okay? So e power minus infinity is 0 minus e power 0 is what? Or you can say minus 0, 1. So 0 minus 1 is 1 plus 1, so that is 1 by s. Therefore the Laplace transform of one constant is 1 by s. And please do remember that e power minus infinity is 0 and e power infinity is infinity, okay? Now let's take the second standard form. If f of t is equals to t, then what is Laplace transform of f of t, which is Laplace transform of t? Okay, now we know the formula and just substitute. So the Laplace transform of f of t, which is Laplace transform of t, is equals to integral 0 to infinity e power minus st into, just remember this formula. What is f of t? Into t into dt. So this is in the form of, I have explained you, right? Integral uv. So identify the first term, which becomes the constant. The differentiation becomes the constant easily. So we'll take this as the first term and this as the second term, okay? Okay, so what is the first step you have to do? So first step is completed, right? You have to do second step, that is first step into second term integration, okay? First term is t into second term integration, that is integral of e power minus st, which is in the form of e power ax dx, that is e power ax by a. So integral of second term is e power minus st by minus s, right? Next what you have to do? You have to write alternate signs, that is minus. And fourth step is again derivate the updated value of first term. Updated value of first term is t, so derivate this, that is derivation of t is minus 1, and you have to do the integration to the updated value of the second term. So this is the updated value of second term and do the derivation for this, okay? See, we are doing the integration with respect to t. So s is constant, you have to consider as the constant here. So integral of e power minus st by minus s. So you just have to do the derivation for integral e power minus st. That is for your understanding, I'll just write here minus s. You have to do derivation for this, okay? Into integral 0, limits are from here to here. So t into e power minus st by minus s minus 1 by minus s. Integral of e power minus st is e power minus st by minus s 0 to infinity, which is equals to this will become t e power minus st by minus s into s is s square, right, by s square into e power minus st, and limits are from 0 to infinity. Now what you have to do, just substitute the upper limit and lower limit in place of t, right? That is, first substituting upper limit, that is t, right, minus s, right, minus infinity in place of t into e power minus infinity divided by s, minus, substitute lower limit for this first term, that is 0. T value, in place of t value substitute 0. 0 into something is 0, so that becomes 0, right? Okay, fine. Or else just substitute in this manner. First substitute the upper limit for this whole thing, that is infinity into e power minus infinity by minus s minus 1 by s square into e power minus infinity. In place of t you have to substitute infinity, right? Minus, there is minus, right, upper limit minus lower limit. So first upper limit minus lower limit. Lower limit is 0. Substitute for this whole thing 0. T value 0, that is 0 into something is completely 0, minus 1 by s square into e power minus s into 0, that is e power minus 0. Calculate this. E power, what I have told, e power minus infinity is 0. So this becomes 0, minus 1 by s square into e power minus infinity, again 0. So this whole term becomes 0. 0 minus 0, 1 by s square into e power 0. 0 minus e power minus 0 means 1, right? 1 by s square, which is equals to 0 minus, this is this will become 1 by s square. And therefore the Laplace transform of f of t, that is Laplace transform of t is 1 by s square, or you can write 1 factorial by s power 1 plus 1. Okay, so I'll just highlight, that is, I'm just writing here, Laplace transform of t is 1 by s square. Okay, this is the second standard form of Laplace transform. So I'll be explaining more standard forms in the coming videos. Please do check the playlist. I'll be uploading all the videos of Laplace transform in the playlist. Please do check. Okay, thanks for watching. Do like, share and subscribe for more videos.